All right, let's get started. We have our first related rates handout here. It's going to start with some notes. We got some stuff to fill in the blank on the left side, but then also we've got some problems to do on the right. And then eventually it's going to turn into, I think it's after page 3, we've got just some examples, just more practice problems for you guys to work on. All right, so let's start off with the left side over here. It says a related rate is when there are, and I'm going to go ahead and fill these in, you can follow along, when there are two or more rates or derivatives in one problem, usually involving a shape. So it could be like a dx dt and a dy dt, or a dA dt for area and a dV dt for volume, something like that. All right, to solve a related rate, we like to memorize the acronym SREDWOO. SREDWOO, let me spell it out right here. SREDWOO. SREDWOO. And a great way to remember this is that silly rhinos eat donuts with unicorns. Just a silly way to remember it I got from another teacher, Mr. Lundstrom up at Paloma Valley. All right, SREDWOO, silly rhinos eat donuts with unicorns. All right, what the acronym stands for. First up, the S stands for sketch the situation. You only do this step if you don't know the equation and you don't know what kind of shape is given, okay? So you don't have to sketch every single time, but sometimes it's helpful. Next up, we want to find the rates. In other words, what rate did they give you? What rate are they asking for? Is it about a dA dt, a dr dt? What's going on there? Next up, we want to make an equation. So E for equation, right? SRED, woo. Make an equation involving only the rates from step number 2. And then let's see, number 4, take the derivative of this equation. So find an equation, take its derivative. And then we're going to plug in the when and solve for the missing rate. Okay, and then we're going to write down our units. In other words, it's usually going to be a word problem. Not always, but when it is a word problem, we got to make sure we think about units. Okay, if it's not a word problem, then we can skip that part. All right, when we talk about the when, oops, I don't know what that was. We talk about the when over here. I'll explain what that means when we start doing a problem. So let's do that right here. Our first example here, it says find dy dt when, I would like you to go box up the when right there, and I want you to put him in jail. He can't come out until we've taken the derivative. Okay, so find dy dt when x equals 3, given y equals x cubed minus 5x plus 2, and dx dt is equal to 2. So we were given some information. So our goal is find dy dt. Okay, so that's the little goal right there. And then we know dx dt is equal to 2. So those are your rates. Okay, there's no need for a sketch on this, but going through our list, we don't need a sketch. The rates, these are the two rates that are involved, the dy dt and the dx dt. We need to make an equation. Well, they already gave us an equation, so I'm just going to copy the equation with a little bit extra spacing because we're about to take a derivative of both sides. In fact, I'm going to sneak some parentheses around this and some parentheses around that, and we're going to go d dt of both sides. Now we're respecting time, okay? Keep in mind, there's a t down here at the bottom, and there's a t down here at the bottom, so we need to respect t on this. Now the left side is simply dy dt, so that one worked out really nicely. The right side, we're going to go normal derivative rules, 3x squared, but attach a dx dt, minus 5, but there's an x there, so you have to go attach a dx dt, and then the 2 is a constant, so that's just going to go away. All right, at this point, we're looking at this going, okay, do we have everything we need? Specifically, we have a dy dt over there, we have an x value we can plug in here, we have a dx dt we can plug in there, we have a dx dt we can plug in there. It's time to go plug in. Okay, so we are plugging in the whens, all right, and then if there's units, we'll write down the units. I don't see any units, so I'm just going to go dy dt Let's go ahead and plug in our x. That's right there. X equals 3. So that'd be a 3 squared dx dt. Oops, we know what dx dt is. Silly Raz. All right, let's go plug in a 2 for that. And then we got a minus 5 times the 2 again. All right, that would be your AP Smiley. If you had units, you would put it on right there. But on the AP exam, you could stop there. All right, this does simplify though. That's 27 with the 3 squared times 3. And then times 2, that's a 54 minus 10. So I believe the answer is 44. We don't have any units, so we would just stop right there. All right. So there we go with the find the equation. And then I'll point to the same thing. We took a derivative. And let's see what else. Oh, we found the rates over here. And then once we had that derivative, then we started plugging in, right? And evaluate, and we didn't have any units to worry about. Let's move on to the second one. It says find dr dt when r is equal to 3. There's your when. Box it up. Feel free to pause the video at any time if you need to slow it down or back it up a little bit. So we have an equation already. And let's see, they're looking for dr dt. That's our goal. And they gave us dv dt, which is equal to 7. Okay, so keep your eye on the prize. So we'll start with our v equals 4/3 pi r cubed. And we're going to jump in there and we're going to take a derivative of both sides. And you guessed it, d dt of the left, d dt of the right. So the left side, super simple. Just read the left side without the parentheses and you're going to hear yourself say dv dt, which we already know. They gave us that as 7. The right side now, there's a 4/3 and a pi, but now you're taking the derivative of this r cubed, which will be a 3r squared, but again, you're respecting time, so you're going to attach a dr dt. Basically, every variable except for t, every time you take a derivative of a new variable that's not t, you're going to attach a d that variable dt to it. So dr dt or dv dt. Okay, we have a derivative. So following our shred woo, let's go back to it. Sketch, we didn't need a sketch. The rates, we wrote those over here. Next, make an equation. Well, the equation was given. Take a derivative, we just did that. That's right here. Time to plug in the when and write down the units. All right, we're going to plug in not just the when, but we also have the dv dt. That's a 7. Oh, I didn't mention these 3's right here. These 3's just cancel out. So maybe I'll clean this up a tiny bit first. That's probably a good idea. So dv dt is equal to 4 pi r squared dr dt. So there's a better form of that derivative. You don't have to. You could just plug in what you had before, but the way you had it before. But I like to clean it up when you can. All right, so here we go. 4 times pi times r squared. And we don't know dr dt. I'm going to move that over here. So we have 7 equals, let's see, 9 times 4, that's 36 pi dr dt. And your job here is to solve for dr dt. So we're going to divide both sides by 36 pi. You don't have to show that if you don't want to. You can just jump straight to the answer. So dr dt is 7 divided by 36 pi. Now we don't have any units. But if the radius were in inches, that would be inches per second or inches per, a minute or something like that. All right, that's it for the second one. Moving on to the third one. Let's switch over to some red here. Okay, so now we said find dy dt when x equals 2. Jail your when. We don't get to use him until we've taken a derivative. And we know that y has to be greater than 0. Given x squared plus y squared equals 20, and dx dt is equal to 5. So let's copy down our equation over here. Oops, that's a 20. And then I'm going to write down my rates. So dy dt is the goal. Dx dt was given. So we have our equation. Let's go take a derivative. Let's see, how about some blue? So we're going to go, oops, let's put that up top. We'll go right on here. So d dt of all of this, and then we'll go d dt of that. Now, d dt of a 20, that's just going to be a 0, right? We know that. Over here, you're going to get a 2x dx dt plus a 2y dy dt equals 0. All right, we're looking good. I think it's time. Once we've taken a derivative, you can free the when. Free the when. We can go plug in x equals 2. However, I don't know if you caught this, but we have an x to plug in. We have a dx dt to plug in. And of course, dy dt, well, that's a special thing that we're looking for. But we do not know yet what y is. So we're going to have to go figure out what is y. Okay. At this point, we're going to take our original equation, x squared plus y squared equals 20, and we're going to plug in the when. That would be a 2 squared plus y squared equals 20. So just take that x equals 2, and we're going to solve this little baby equation. So that's 4 plus y squared equals 20. That means y squared equals 16. So y should equal plus or minus 4. But remember, we saw this earlier, this y greater than 0 stipulation, and we didn't really talk much about like, what do we do with that? But now we know y is going to be equal to positive 4. Okay, it's time to go plug in. Here we go. Back to it. 2 times x, which is 2, times dx dt, which is 5, plus 2 times y, which is 4. dy dt, we don't know yet. Cleaning this up, that's 4 times 5, that's 20, plus 8 dy dt. From there, we're just solving. Don't think too hard. 8 dy dt is equal to negative 20. Running out of space, but we can do it. I'm so close to the bottom of the page. There we go. And we'll reduce that. That would be negative, let's see, 10 over 4 or negative 5 over 2. And again, no units to speak of here. We don't really have a word problem. So, all right, that is it for the third one on the page. We're done with page 1. Don't forget, shred woo. Silly rhinos eat donuts with unicorns. Shred woo. Sketch, that's this guy. The R stands for rates. Go get your rates, write them down. That's like what we did over here. Get yourself an equation. A lot of times it's just given to you. Other times you'll have to come up with it yourself. Like if they're talking about the area of a circle, you would go to yourself, oh, what's area of a circle? A equals pi r squared. Got it. Write down that equation. Then take the derivative of that equation, respecting t. All right, then we got the W. Once you've taken the derivative, you get to go plug in the whens. Okay, and then at the end, if there are some units, we'll make sure that we do the units. Okay, in other words, write down the units. Inches per second, meters per hour, anything like that. All right, so the next page, here we go. If you need to pause it, go ahead and pause it anytime. Let's see, we're moving on to some basic geometry formulas that you're expected to remember. Perimeter of a square. I'm just going to go 4 times x. Some would say 4 times s. My s's look like 5, so I'm going to stick with x. The area of a square would just be x times itself. The surface area of a cube, we'll use capital S for that. There are 6 faces. So if I were to draw a little cube right here, boop, 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 boop. Well, I've got 3 faces that you can see, but there's also the 3 faces that you cannot see. So that's 6 of those, and each one has an area of x squared. Of course, the volume of a cube is just going to be length times width times height, which are all the same value. They're all that x. So I'll just go x cubed. Circumference of a circle, we've got 2 of them. We can go c equals pi d or c equals 2 pi r, depending on what's given. If they're talking about a radius, you would use the second one. If they talk about a diameter, use the first one. The area of a circle is just pi r squared. Again, all of these things that you should probably know already. All right, maybe you don't remember or don't know the surface area of a sphere. This one happens to be 4 pi r squared, which is interesting because it looks like 4 times just the area of a circle, but it's a sphere, it's a 3-dimensional object now. And then the volume of a sphere, is 4/3 pi r cubed. And coincidentally, If you take the derivative of the volume, you're going to get the surface area. Think about that for a second. 4/3 stays out front, the 3 comes down, and you still got your pi and your r and your squared. 3's cancel, 4 pi r squared. Look at that. My goodness. What about area of a circle? Check it out. Take the derivative. The 2 comes down to the front, 2 pi r to the 1. That's 2 pi r. That's the circumference, y'all. Also known as the derivative of the area. Interesting. Nice little twist there. All right, let's get into these other examples over here. It says if the radius of a circle is increasing at a rate of 3 inches per second, how fast is the area of the circle increasing when the radius is 2 inches? Okay, so again, we always want to be thinking about Shred-Woo. So maybe you want to draw a picture, maybe not. I think I know what a circle is, but I'll go ahead and draw you a little circle here, and we'll put a little radius there. Next up, r, that's the rates. So the radius of the circle is increasing. So the radius is increasing at a rate of 3 inches per second. That means dr dt is 3 inches per second. Now, we've got units on there. We also, I don't know if you noticed it, but I chose a positive 3 because it said increasing. If it said decreasing, I would have put a -3. How fast, that sounds like a rate question, is the area of the circle increasing? Okay, so we're looking for the rate at which the area is increasing. When, let's go jail the when. We're going to go jail that guy. We also, let's see, did I write that on my notes over here? No. Actually, no, we're good. So we have an A and an R. And we know what relates an A and an R. We have an area of a circle formula. It's A equals pi r squared. So let's go take a derivative of r pi r squared. So we're going to go d dt on the left, d dt on the right. As far as the Shred-Woo goes, let's see. We've got our rates written down in that little box up there. We've got our equation. We are about to take a derivative, and then we'll go plug in the when. So what we have here is a dA dt on the left. And then we have a pi times a 2r. 2 comes down, right? Reduce the power to a 1. And then you have a dr dt. If you prefer, you can make that a 2 pi r dr dt. All right, it's time to plug in the when. The when was 2 inches. We also knew the rate for the radius. So we're going to go ahead and plug those in. We do not know dA dt, so that's what we're searching for. I'm going to go ahead and put the 2 pi together like so, because that seems more natural. And then the radius that we're freeing up is that 2 inches. And then the rate was 3. Now, I'm going to go ahead and throw in the units here. This was 2 inches, and then we got inches over here as well. And if you multiply these all together, it's 2 times 2, which is 4, and 4 times 3, which is 12, and stick the pi back on there. But your units are sitting right there too. It's inches squared per second. So there you go. Now that makes sense to us because area is always a square unit thing. It's a square inches or, 52 square yards or, you name it. It's always going to be square somethings. And because it's a rate, we're going to have to put a time unit on the bottom of that. So inches squared per second, because that's the way they gave it to us. Whoop. All right, there we go. Nice little word problem. Followed our Shred-Woo. We are good to go. Oh, by the way, I didn't check off the U. We did the units. Good for us. All right, let's move on to the next one. Okay, here we are on, let's see, middle one on the page. On page 2, if the area of a square is increasing at a rate of 3 square meters per minute, that sounds like this. Area, increasing means positive, 3 square meters, or you could say meters squared per minute. There we go. At what rate are the sides increasing? Now it's just a square, so if you want to draw a picture, you can. Here's an x, here's an x. So we're just going to call it dx dt. They're asking for the rate at which dx dt, at which x is changing or increasing when the sides. You can put the the when bar if you'd like there. You don't have to. So there we go. Shred woo. Sketch it. We did a little sketch of the square. Next up, the rates are written down. We need an equation. It's just the area of a square, and the area of a square can't get much simpler than this. A equals x squared. Let's go take its derivative. So we're going to go d dt on the left, d dt on the right. So that'll get us a dA dt on the left, and then a 2x, that's an equal sign right there, and then a 2x dx dt on the right. There we go. So you've got your derivative. It's time to plug in the when. Oh, I forgot to jail the when. You're supposed to jail them at the beginning, but okay, now it's time to go plug in the when. Okay, we can plug in our area over here, rate. Our area rate was 3, and then 2 times the x, and the x was 5, and we don't know dx dt. So we're just solving for that. So that means I'm going to rewrite this. 10 dx dt is equal to 3. I just switched sides there. And then we'll divide both sides by 10. So it's 3 over 10. And if you think about it, this is a side length. And these are measured in, well, the area was changing at a rate of meters squared per minute. So that means that the side length, this must be in meters, right? So that'll be meters per minute. And it makes sense to me that's a positive answer, 3/10 of a meter per minute. If the square is growing, right, this area of the square is increasing, well, the side length is going to be increasing as well, obviously. All right, that's it for that one. Almost done with page 2. Let's see what we got here. It says when the sides of a cube are 3 feet long, here goes my picture. I'm going to draw a little diagram. Boop, boop. There we go. This is an x, that's an x, that's an x. The volume of the cube is decreasing. Okay, so that means dv dt, it's decreasing. Oh, we got a when up here. I should go ahead and do this since I forgot it last time. Go jail up the when. You don't get to use that till the end. Let's see, the volume of the cube is decreasing. That's why you put a negative at a rate of 10 cubic feet per hour. There we go. How fast? That sounds like a rate question. Are the sides of the cube changing at that instant? So that means we're looking for dx dt. All right, as far as shred woo goes, sketch, got it. Rates, got them. Equation, I'm about to. It's the volume of a cube. Don't overthink it. Length times width times height, but they're all the same. They're all in x. Equation's done. Derivative's about to be done. Let's go take a derivative of both sides. If you want, you can just go d dt once out in front of the entire equation, if you'd like to do that, a little shorthand notation. So that means we'll have dv dt on the left, 3x squared dx dt on the right. And I think it's time to plug in our when. So let's see, 3 is going to go in. What else goes in? I already know my -10. So that x, that's a 3, and then you're going to square it. Then you got your dx dt, which is what you're looking for. That's your goal. All right, so that means we got -10 equals 9 times 3, which is 27 dx dt. So that means dx dt is equal to -10/27. And I just realized I should probably move that over a little bit so I can put some units on it. Now this is the rate. Keep in mind, this is the rate at which the side length is changing, okay? And it's negative, that makes sense to us. Look at that, makes sense. Because remember, the volume was decreasing. If the volume of cube is decreasing, that means there's less to it. That means the side lengths have to be getting smaller as well. All right, now if this were in feet cubed per hour, well, a side length is not going to be cubed, but it'll still be in feet, and it's a rate, so you got to put it per hour. There we go, -10/27 feet per hour. All right, great time to pause it if you need to. Go ahead and do that. All right, finishing up my shred woo off to the side here. We did the whens, we did the units, we're looking good. Moving on, we got some more basic shape practice here. Let's see. All right. There's something interesting happens on this first one here on the top left. It says when the sides of a square are 7 inches long. That's a when if you didn't catch it. Grab that, save it for later. The perimeter of the square is increasing. So that sounds like a rate. dp dt is increasing, so it'll be positive, and that'll be 3 inches per second. That's a little weird. My screen kind of slid over right when I was writing it. There we go. Next up, how fast are the sides of the square changing in that instant? So I'll just go dx dt equals what? Okay, I don't think I'm going to draw a picture this time, or I don't know, maybe I will. We're just going x plus x plus x plus x, so our perimeter is simply 4 times x. So now it's time to take our derivative. D dt of all of that. And like I said before, if you're just trying to figure out the left side here, if you just read it without the parentheses, you're going to hear yourself say dp dt. The right side is also very simple. It's just going to be 4 dx dt. Remember, the derivative of 4x is simply 4, right? So you have to attach the dx dt. Now, it's time to free the 7. But what are you going to do with it, right? There's no place to put it, which is very strange. I can plug this guy in. So that's a 3 over there, and that equals 4 times dx dt. If you divide over and switch sides, you're going to get 3 divided by 4. Let's see. This is the rate at which a side length is changing. So if you go back to the units, that was inches per second. All right. Strange thing happened here. I don't know if you caught it. The side length is actually irrelevant. When finding dx dt. Interesting. It's just a special case that happens sometimes. Interesting. All right. All right, let's move on. Let's see. I was thinking of maybe leaving one of these for you guys to do. Let me pause it for a quick second. Maybe you want to do the same. Catch your breath. Make sure we're on track. All right, so let's do this next one here on the top right, and I think I'll save the bottom two for you guys to do on your own. It says if the radius of a sphere is decreasing at a rate of 4 miles per minute, so that sounds like a dr dt, and it said decreasing, so you should be thinking about the sign right now. If you want to say it out loud on the count of 3, tell me if it's going to be positive or negative. Here we go. 1, 2, 3. And it's either awkward silence right now, or some of you said negative. I'm not sure because I'm not there. It's negative. And we're going to go 4 miles per minute. 4 miles per minute. How fast, that sounds like a rate as well, is the volume of the sphere changing? So that's dv dt. That's what we're looking for. So those are your rates. I didn't draw a sketch. Let's get our shred woo going here. A sketch would just look like this. It's a sphere. And then you can just draw like the equator, and you can do the backside of the equator, like a dashed line back there. And there you go. The rates are written down. I need an equation, and it involves volume. Okay, so we gave you some formulas back over here. Let's go back a page. Here we go. Volume of a sphere. There it is. 4/3 pi r cubed. Let's bring it back down here. The volume is 4/3 pi r cubed. All right, there's a when in there. I didn't jail the when yet, so let's go do that. When the radius is 3 miles. So jail that guy. He doesn't get to come out until you've taken the derivative. But let's go take a derivative right now. Here we go. D dt, I hope you're thinking. So we got a dv dt on the left. I'm going to go ahead and let the 3 come down and cancel the other 3 right now, because 3 times 4/3 is simply a 4. Pi r, reduce the 3 to a 2, right? So your power has reduced. And then you attach a dr dt. Looking good. All right, it's time to go plug in what you know. Free up the when. So the radius was 3, so we'll go 4 pi times 3 squared. And we also know the radius's rate was -4. And then dvt is dv/dt is still missing. That's the piece we're looking for. All right, combining all of these factors here, you've got 4 times 4, which is 16, times 3 squared, which is 9. And that is 144, and it's negative. Don't forget the pi. And we're going to take the units that we had that were up here, and we're going to change that to a cubic thing. So miles cubed per minute. And there is your answer. Anytime you see volume, you should be thinking cubic this, cubic that. If it's a rate, it'll still be cubic this or cubic that, but then it's going to be per seconds, per minute, per whatever time unit you've got. All right. I'm going to have you guys do these two on your own or with your group. And let's slide down to the next page. So we are now on, what page is this? Page 4. We're just going to do one of these real quickly here. We're looking at number 1. It says find dy dt when x is equal to 4, jail the when. There's an equation right there. Let's go take a derivative. So we're going to go d dt of x squared plus y squared equals d dt of 25. Okay, so then we'll get 2x dx dt plus 2y dy dt. This is similar to the latter problem that I was demonstrating the other day, if you remember seeing that. So we need to plug in the x. I get that. So I can easily plug that in. I also know the dx dt. I do not know the y, nor do I know the dy dt. But the dy dt, that's supposed to be missing, right? Because we're searching for it, right? So it would make sense that we're going to take the original equation then, take this guy, and we're going to go plug in the x that we know. 4 squared plus y squared equals 25. That means 16 plus y squared equals 25. If you subtract the 16 over, you get yourself a 9. If you square root, you get a plus or minus 3. Now, we're searching back up here, and we're looking for any stipulation, any constraint that says make sure y is positive. We saw that earlier today. Or maybe make sure it's negative. We don't see that. So what does that mean for us? We got to calculate twice. We've got to calculate twice. So we are going to use, well, we're not going to use a blue highlighter. We're going to use 4 goes with 3 and 4 goes with -3. So at this point, I'm going to go ahead and start with the 4, 3. If using 4, 3, it's going to look like this. 2 times the 4 times the dx dt, which was 3, plus 2 times the y. I do not know the dy dt. All right, solving that. Let's see, we're going to get 12 times 2, that's 24, plus 6 dy dt equals 0. That means 6 dy dt will equal -24. And that means dy dt will equal -4. Okay, so that's one of the answers. Now we've got to go do the other one. So if we have 4 and -3, well, it's going to look pretty much the same, except this 3 right here will become a negative. So it'll be 2 times the 4 times the -3. Okay. Oh, wait, I lie. Be careful here. That was a different thing. That was dx dt, and that's actually still a +3. That was a close call. So there's that. And then over here, this guy. So let me get rid of this arrow. So this guy, that was the y, right? That's where you're plugging in the y. So that's where you're going to put the -3. Then you got your dy dt that we don't know, and it's still equal to 0. So again, with the 24, but this time you got a -6 dy dt. So that means -6 dy dt is equal to -24. So dy dt will be a positive 4 this time. So that happens sometimes. Don't let it bother you. You just need to kind of deal with it as it comes. No big whoop. All right, we're going to save number 2 and 3 for you guys. I was going to tackle a number 4, and we got one more. So if you need to pause it, go ahead and pause it, whatever you need to, or back it up, back the video up. I'm going to pause it myself just for a second, catch my breath. I'll be right back. Oh, hey there. Fancy meeting you guys here. All right, we're going to skip over 2 and 3. Let's go do that number 4 right there. And then I think we've got maybe one more to do after that. All right, it says find dy dt when x is equal to 8. Okay, let's jail the when, like we normally do. Given xy equals 4, I'm going to go ahead and copy down that equation. If you want, you can write down the goal, and then you can write down the rate that they gave you. Okay, so those are the rates. We don't need to draw a picture, but we do have an equation already, and it's time to go take its derivative. This one's interesting. This is why I chose it, because we get to use the what rule? Yes, exactly. You said product rule, right? Good. So let's go do the product rule. I'm going to go white out the page number there first. All right. So here we go. We've got an f and a g, and we're going to go g times f prime plus f and g prime. And of course, a 4 is a constant, and that goes away. Awesome. All right, we're looking pretty good. Let's see, they gave us a when. Our when was just x was equal to 8. I don't think we have enough information right now. I can plug in a dx dt. I know I'm searching for dy dt, so that's fine. And then my x, I have that. I can plug that in. But I do not know, we do not know what y is. So let's take the original equation. Let's copy it down. Let's plug in what we know. We can free the x. X was 8. So that means y is equal to 4/8, also known as 1/2. Okay, now we're ready. 1/2 of dx dt plus x was 8 times dy dt. And in fact, I don't really need a parentheses there. It's just a little extra. 1/2 of 10 is 5. So we're going to say 5. Let's draw a little line here. 5 plus 8 dy dt is equal to 0. That means 8 dy dt is equal to -5. And then dy dt is equal to -5/8. All right. We're looking real good here. I think, in the interest of time, the next one that I was going to do with you guys, go ahead and box that up. There are no units, nothing to do there with units. The rest of these, I'm going to have you guys do on your own or with your group. We're just going to say skip number 8 for now. We'll save that for a later date. Okay, I don't want this video to keep on going because it's already been a long time already. So thanks for hanging in there. You are going to work on the rest of these. You're going all the way through the end. So basically, I want you to finish everything except for number 8. Okay, don't obliterate it, don't cross it off. Just say skip for now, and we will do that one together some other time. All right. Thanks so much for watching. Hopefully it was helpful for you. If you need to, you can go back and watch it again. That's it. We'll see you next time. Bye, guys.